Okay, let's go over our sample final. So we've got radian measure, and we're supposed to change it to degrees in decimal format. Okay, so pi is equal to 180 degrees, so I'm going to go 4 times 180 divided by 9, and I get 80 degrees. Change it to minutes, seconds. Well, it's no decimal, so there's nothing to do. 80 degrees. Now, if it were some decimal, we would subtract the 80 and then take the decimal times 60 to get the minutes. Subtract the whole number, take the decimal times 60 and get the seconds. But this is 0 minutes and 0 seconds. Probably should have thought about that one a little bit more before I made that question as a sample one. How do I change this to decimals? This 35, 30, 57, 9. So I got 35 degrees plus 57 out of 60 minutes. 57 out of the 60 minutes it takes to make a degree, plus 9 out of the 3,600 seconds that it makes a degree, 60 times 60. And I get the decimal form for that is 35.9525 degrees. And to change that to radians, I have to multiply by 1 that has the degrees canceling. So I do 180 in the denominator and pi in the numerator. And that times this would make it radians. So I got to take my answer times pi divided by 180 times pi divided by 180. And I get 35 degrees something 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 is 0.627489 radians. Okay. Now I have to put the calculator because it says get the exact value, no decimal approximations. So the cosine of 60 is up here. Cosine is 1/2. So I got square root of 2 times 1/2 minus 4 times 3 pi over 2. Pi over 2, 2 pi over 2, 3 pi over 2. That's the sign there is -1. So I got -4 times -1. So I get square root of 2 over 2 plus 4. If the sign is -5/9 and the tangent is greater than 0, sine is negative in quadrant 3 and 4, and the tangent's positive in 3, so we must be in this quadrant. And we're supposed to find the cosine. Well, then the cosine would have to be negative also. So when I do sine squared plus cosine squared equals 1, subtract this from there, so this is 1 is 81 over 81 minus 25 over 81, so 81 minus 25, let's see, take away 30 is 51, 56. I get cosine squared theta phi is 56 over 81. So I take the square root, and it's the square root of 56 over square root of 81, 9. And the cosine is supposed to be negative in this quadrant. The cotangent is simply the reciprocal of the tangent, or it's cosine over sine. So it's negative square root of 56 divided by 9 over negative 5 divided by 9. So it becomes positive, and multiply by 9 on numerator and denominator will get rid of the 9. So I get square root of 56 over 5. And the cosecant is the reciprocal of the sine, so that's equal to negative 9/5. Page 2. All right. So this is a right angle, so we can just use our regular trig functions. So if that's 90 and that's adjacent to the angle, the tangent gives me the opposite tangent of the angle is the opposite over the adjacent. So I can get this side by multiplying by 52 on both sides. So mode has to be in radians. 52 tangent 4 pi divided by 7. Did I not change? I did change my mode. Quit. Uh-oh. I think maybe. Let's see. I made a triangle that's not possible. That angle is bigger than 90, and so we'd have a triangle that's more than 180. So this is oopsie on me. So let's change it to just pi over 7. So if I make it pi over 7, then we should get something that makes sense. So take the 4 out of there. Okay, now this could be 25.04. That's what happens when you make tests too late at night. Okay, so this didn't make sense. It was over 180 degrees, and a triangle only has 180 degrees. Okay, and this angle y would be, well, since I figured, let's see, I could do pi divided by 7. Let's make it 180 divided by 7. That's this angle in degrees plus 90. Take that away from 180. And this would be 64.2829 degrees. And I can go with this 25.04. Again, that's changing the problem. If I do that, squared plus 52 squared, and then take the square root of the answer, and I get this side to be 57.72. Okay. Apologize. Take the 4 off to the 4 pi over 7 because that makes an impossible triangle. I could have made it a 3 or a 2 and it would have worked, but I just get rid of the 4. Okay. Simplify sine of over tangent. So this is sine phi divided by tangent, which is sine phi over cosine phi. So if I divide, I have to invert and multiply. So this is sine phi times cosine phi over sine phi. The signs cancel, and I get cosine phi. Another way to look at this is sine phi over sine phi over cosine phi. And to get the denominator off the denominator, I'd have to multiply numerator and denominator by cosine. So that cancels that. And then I have sine over sine, which is 1 times the cosine, which is cosine phi. 1 minus sine squared is cosine squared phi. Secant is 1 over cosine phi. So this turns out to be cosine phi also. And see, this one, there's several ways to do this one. I'll do it this way, and then I'll talk about another one. So if I take cosine squared times this, the cosine squareds would cancel, and I get sine squared phi. Cosine squared times 1 is cosine squared phi, and sine squared plus cosine squared is 1. Now I could have thought of tangent squared phi plus 1 as secant squared phi. There's an identity that says that. So we'd have cosine squared phi times secant squared. And secant squared is 1 over cosine. Squared. So the cosine squared cancel, and we get 1. All right, page 3. Amplitude, absolute value of -3. Period, it's 2 pi divided by 2, which is pi, or you can graph it and see the period. Midline, this thing has been moved up +1, so it's y equals 1. And it's been shifted right 0.5. All right, now we got to write equations. This is -2, so it looks like the midline is about -1. And it looks like it's at 0. It's starting at the top. So this looks like it's a cosine curve. And it looks like the period is top to top. Looks like it's about, that's a half. That might be a third, a 2/3. 1/3, 2/3, 3. So 2/3, so that's 2 pi over 3. So I'm going to do 2 pi divided by 2 pi over 3. So that turns out to be just 3. X, not shifted sideways, and it's going 2 units above the midline and 2 units below, so 2, and it's starting up like the cosine is, so it's plus. So that must be the equation. Then when you have these, you want to make the curve that touches them. And find out its equation. So the midline on this one is also -1. And it looks like a sine curve. And it looks like the period is, it looks like it's about 2 units. From here where there's an asymptote to where there's an asymptote, up, down, and then it's ready to repeat after 2. So the period is 2. So it's 2 pi divided by 2, which is just pi x. And it's right on. It's not moved sideways, so there's no horizontal shift. And it's going up and down. And this curve is going 1 above and below, so the amplitude is 1. Now I need to make it this curve and not this curve. So this is the reciprocal of the sine. So it would be y equals 1, not sine, but cosecant of pi x minus 1. Or you could put a divide there, and that would also do it. If you do it on your calculator, if you do it in Desmos. Next page. Okay, so sine inverse comes out of these two quadrants for the principal value. And if it's negative, we got to go down here, and it's a half, so that's negative 30 degrees, or negative pi over 6. Cosine inverse. Cosine comes out of the first and second quadrant, and it's negative, so we have to go out of this quadrant. And negative puts it all the way back there, so that's at 180 or degrees or pi. Can't do negative, it's got to be between 0 and pi, or 0 and 180 for the principal value. Cosecant. Cosecant's the reciprocal of the sine, so this is asking for when the sine is 1/2. Sine inverse. So we're now going to go in the first quadrant, so it'll be a plus 30 or plus pi over 6. Tangent. Tangent comes out of the first or fourth for the principal value. It's negative, so we got to come out of this quadrant. And it's got a square root of 3 in the cosine, so it's longer in the cosine than it is in the sine. So that's negative 30 degrees or negative pi over 6. All right. Hopefully this is a better triangle. Looks like we got a 90 degree, so we can do regular trig on this. And for x, the tangent of x is 49 over 10. So I got to do tangent inverse of that to find x. Tangent inverse of 49 divided by 10. And that's in radians. I have degrees here, so I'm going to go to my mode, change to degrees, and then I can just press enter, and it says x is 78.47. And so I can take that from 90, and I get 11.53. So I got these, and 10 squared plus 49 squared, and then square root. Excuse me. Yeah, so hypotenuse is 50. Pretty much just 50. All right, so if we do the principal value, this would be in the first quadrant because sine comes out of the first or fourth. And so we'd be in the first quadrant because this is positive, and so we got to take the cosine of that where the sine is positive, and so the sine squared plus cosine squared is 1, so 9/49 is the sine squared plus the cosine squared. Some angle is 1. So this would leave 49/49 minus 9/49, which is 40/49 is the cosine squared. So cosine is square root of 40/7. And if you wanted, you could pull a 4 out of that, would be 2 square roots 10/7. Okay, sine is supposed to come out of the first and fourth, but 5 pi over 6 is way over here, and the sine is plus 1/2. So to get it in the first quadrant, I'd have to do not 5 pi over 6, but pi over 6. Okay, exact solutions. So I would subtract the square root of 3 and divide by 2, so I'd have cosine of x equals negative square root of 3/2, and all the solutions are 0 and 2 pi. Cosine is negative square root of 3/2, which means we're there. And that's set in radians. And the other place would be down there, which is 5, 6, 7 pi over 6. So if I divide both sides by 2, I get the sine of 0.5x is 1/2. Sine is 1/2 here at 5 pi over 6 plus multiples of 2 pi, or sine's 1/2 here at pi over 6 plus multiples of 2 pi. And I'm writing this form because we got 0.5x. That's what the angle would be. So now I'd have to multiply both sides by 2 to get rid of the 0.5. So I'd get 5 pi over 3, multiplying this by 2, plus multiples of 4 pi, 2 pi over 6 pi over 3 plus multiples of 2, 4 pi, multiplying both sides by 2 to make this. So x is either these or x is these. The only ones that on this that are between 0 and 2 pi is the 5 pi over 3 and the pi over 3. Find all the solutions. So we have sine of x is 3/5. So if I go to my calculator and do sine inverse of 3 divided by 5, I get, let's go to radians. In radians it says, I get 0.6435 plus multiples of 2 pi, and the other ones for sine, since sine is someplace and this angle and 180 or pi minus that angle, so then I've got to go pi minus that answer, and I get the other ones are 2.4981 plus multiples of 2 pi. So there's all the answers for that one in radians. This one, so I subtract 2 and I get 2 something squared minus 3 something minus 2 equals 0. See, if I try to factor that, that would be 2y and y. And if I put 2 here, I get 4y, and 1 there, I get 1. And if this is minus 4 plus 1y, minus 4y plus 1y is minus 3y. So I have 2 sine of x plus 1 equals 0, or I have sine of x minus 2 equals 0. This can't happen because this says sine would have to be 2, so there's no solutions there. This says sine of x equals minus 1/2, and sine is minus 1/2 here and there, so it's minus pi over 6 plus multiples of 2 pi, and also 5, 6, 7 pi over 6 plus multiples of 2 pi. Okay. Excuse me for a moment. Okay, a weight is hung on a spring 4 feet from the floor. So the floor, this is 4 feet. And this is the spring. It is pulled down 2 feet. And released at time 0. So it's going to go up and down and up and down and up and down, centered around 4 feet from the floor. So it's going to have a midline of plus 4. I'm pulling it off, so it's going to be cosine. And it's going to be starting at minus 2 below, and it's going to go up to 2 above, and then down and up and down and up and down. We're not going to worry about, or does it? Yeah. And let's see. and it makes one complete oscillation every half second. So we got 2 pi divided by 0.5, so that's 4 pi t. And that's going to be the height from the floor at some time. And determine when it is at first time it's 4.5 feet from the floor. So I'd have to set this equal to 4.5. So if I subtract 4, I get a half and divide by -2, so I get -1/4 equals cosine 4 pi t. So I got to do the cosine inverse of 0.25, negative cosine inverse of -0.25, -1/4. And I get 1.83823 is 4 pi t, and then I got to divide by 4 pi, parenthesis, 4 pi, close parenthesis, and I get 0.145 seconds. That's, yeah. Now I could have done this graphically. Mode function, and gone to y equals and typed in -2 cosine 4 pi x, close parenthesis, plus 4. Let's just graph it. Okay, so let's go zoom 4. That might be a better graph. No, that's what I had. Not any better. So it started at 2, went up, and the first time it hits, it's right in there. So I need to zoom in there. So I'm going to move up to here and then go zoom in there. And so I want to know when it gets there. Let's go up higher and press zoom in there. Okay, now I'm going to add a line. I want to see it when it's 4.5. There it is, 4.5. That's the time. Let's find that intersection. Second, calculate the intersection of that line, the blue one, and the red one. And here's my estimate. And it says 0.1451. 1.145. That matched. Okay, parcel of land is shaped as a triangle. One side is 340. The angles at each end are 55 and 65, and they could be either way. It's not going to make a difference. I sketch the parcel. Find the other angle. That's pretty easy. 55 plus 65 is 120, so this is 60 degrees. That plus that is 120. From 180 is 60. And the sides, well, I've got this, so I can do law of sines. The sine of 60 divided by 340 equals the sine of another angle over the side opposite. So I'll call this A. And so to find that, I probably should have started with A over sine of 65 equals 340 over the sine of 60. It makes it easier to see. So to solve this, I'm going to multiply 340 times the sine of 65. 340 sine 65 mode, just thought of that, so divided by sine 60, and I get A to be 355.81. Now I could use law of cosines, but I can also do law of sines. Change it to A over, no, B, I'll call this side B, over sine of the side opposite equals any one I know, which is 340 over sine 60. So all I have to do is change my last one from that angle being 65 to 55. And I get this angle to be, or this side to be 321.5.60 rounded. And then the area, I can go side angle side, 1/2 340 times 355.81. Sine of the angle in between those is 55. Let's see what that works out to be. 0.5 times 340 times 355.81 sine 55. The area of this land is 49548.62 square feet. And these are in feet. Okay. Another page. Write in polar form. X, Y. X is r cosine theta times r sine theta equals 5. Convert this to polar form. So the radius is the square root of x squared plus y squared. So the radius is the square root of 13. And the angle is sine a tangent inverse of -3/2. And since x is negative, I'm going to have to add 180. And so I'm doing this in degrees, so mode needs to be in degrees. It is tangent inverse of -3 divided by 2 plus 180 is 123.69 degrees. Draw 2 U's that's that length twice plus V. So here's what this one looks like. Goes from there, oh, I need to put an arrow on it. Started here, went there, there, and so that's the end result. Starts here and ends there. Okay, this page. The rectangular components of this is 4 cosine negative 40 and 4 sine negative 40. .064 and sine is negative 2.571. Let's see if that makes sense. If I go at negative 40 degrees out 4, I should be positive 3 down 2.5. Makes sense. So I need to do 3 of these plus minus 2 of that, which is 10. So the cosine, that's that. 3 of the v's, so that times 3 and minus 2 times 5, so that's minus 10. Negative 0.807. And then I got to do the same for the oh. So now I got to go back.
I remember my grandmother making something like that.
This length, which is 4 sine of that, times 3 of that component, 3 v's in the y direction, minus 2 times 3 times 3, and there we go, and that's negative 13.71, and that would be an answer. Or you could change that to polar by doing that squared plus that squared square root, and then do the angle by doing tangent inverse of this divided by this, and since the x is negative, we'd have to add 180. Unit vector in the direction of v. Well, how long was this thing? Well, the length of it is 25 plus 9. So that's the square root of 34. So the unit vector would be 5 over the square root of 34 and 3 over the square root of 34. Okay, and I think this is the final problem. I got noise in the background here. I hope it's not bothering you. It's bothering me a little bit. 30 at 240. 240 is this direction. 30 and 12 at 210. So 30 and 12 would be shorter. And so I got this one plus this one. Now it might be easiest to do this in components. So 30 at 240. Oh, clear. 30 cosine 240 is negative 15. And change that to sine, and I get negative 25.98.
So this morning I was going.
And the other one is
I don't have to get up. Just in my
12
phone.
cosine
I'm not coming to your house.
210. And sine a 210, which is -6. So then I can add these together. I get -25.39
So how are you doing?
and -31.98. So this would take it. We're supposed to get something that goes out here, so it should be quite a bit negative there and down quite a bit this way. And that's what it's giving us. And I can change it back. Let's just do this one. So I got to go 25.39 squared plus 31.98 squared. Oop.
Kenny Johnson had both knees done, and she said her second knee was so much easier than
Then I got
hers.
to take 2 to the 0.5 square root, and I get
Rehabbing the first knee,
40.
strengthened her second knee.
Point
So
eight,
she had
point
surgery on the second knee.
eight
Like, whoa.
33
You need to be in pretty good shape to go into that.
pounds
And you were. You walk a lot. So.
of force at the angle would be tangent inverse of -31.98 divided by -25.39, and since the x is negative, plus 180. So the angle is at 231.55 degrees. So 40 at -231, somewhere between these two, which makes sense.